Hello guys, welcome back to this video, and in this video we are going to start solving the problems of this seed which is created by FRAZ. So it's a FRAZ DSA seed which contains approximately 1200 curated DSA questions. My target is to give the solution videos for all these problems. So I'll start with the first section of dynamic programming level 1, which is the linear DP. So I'll start with the linear DP. I start with the first problem, and yes, I will use both Hindi and English language in these videos, these solution videos. So let's start the first problem, which is climbing stairs. So the problem is you are climbing a staircase. It takes n step to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? N equals to 2 and output is 2, right? For n equals to 2, output is 2. Okay, so guys, let's first understand this problem. Let me connect my iPad first for just showing you what is happening here. So okay, so the question is key. You have an the example test case is n equals to 2. So for n equals to 2, how many ways are possible? So uh, if you can see here, it's the output is 2. So for n equals to 2, 2 for n equals to 2, it's 2. For n equals to 3, it's 3. So for n equals to 2, the answer is 2, and for n equals to 3, answer is 3. So how the answer is 3? You have restriction. You have one restriction. Restriction is you can only jump one steps and two steps. So okay, so this is the very classical problem of dynamic programming. So we'll start with the just base cases, like when you're solving some dynamic programming questions, and whenever you see the problem where you are able to find out these optimal substructures and repeating patterns, in that case you can use dynamic programming. And uh, when you are solving dynamic programming questions, you have to care about only two three things. The very first thing is, first, try to break the problem in smaller sub problems, right? This is the first thing. Second thing is, try to generate answer manually for smaller inputs. Third is, use this smaller answers to build your final answer. So these are two three steps which you have to follow. And the most important thing is also, whenever you are solving some DP problem, try to define the states of problem. What is the states? Like you have seen in a lot of problems that lot of DB problems that you are just taking DP of some I, or DP of some IJ, or some DP of IJK. Means your DP state is dependent on the parameters, the different parameters. So let's directly jump into the problem and try to think in in that way. So here for n equals to 2, what are the possible options? So n can be 1, n can be 3, n can be 1e5, anything. So we will just go start to build the answer for smaller inputs like n equals to 1. N equals to 1, what is the answer? For n equals to 1, answer is 1. Why? So for jumping into step 1, you have only one option. You can only jump one step, right? For n equals to 2, how many options? For n equals to 2, you can jump from 0 to 2 by taking 2 step, or you can jump from 1 to 2 by taking 1 step. So you have two ways to reach to this 2, right? Right, fine, okay. Similarly, if you just check for n equals to 3, for 3 you can take from 2, you can take plus 1 step, and from 1 you can take plus 2 steps. These are the 2 steps, and so these are the 2 steps from 1, and also from 2 you can from 1 you can come from 0 plus with 1 step, or on 2 you can jump from 0 plus 2 steps and plus 1 step, and 2 from 2 on 2 from 1, right? So here if you will check, you have this path from 0, and you have let me check, you have this path and you have this path. So total number of phase in this problem will be 3. In this test case will be 3. So for 3, the answer will be 3, right? So got it. So here you can see this the construction of this answer 3. This 3 is dependent upon the answers for 2 and answers for 1. So whatever the answers for 2, you can take one more steps and jump into the 3, and also you can uh, jump it from 1 also. So whatever the answer for 1 and 2, the 3 is dependent on that, right? So we will define the state of our DP. So we will define in a way that DP of I is the number of distinct ways to reach at ith steps, right? So DP of I means number of ways to reach at ith step. So let's say you are at ith position. This is some arbitrary number, some step. So from ith step you can come from I minus 1 step, and also you can come from I minus 2 step. So whatever the answer for this I minus 1 step and whatever the answer is for I minus 2nd step, we can just add it and we will get the answer for this ith step, right? So basically our formulation will something look like dp of I will be equals to dp of I minus 1 plus dp of I minus 2, such that I minus 2 greater than equal to 0, right? These are the conditions, and this is the relation for ith step with this previous step, right? So this is the overall formulation for this problem. And if you just try to see the time complexity in this case, so the time complexity will be order of n, and also the space complexity will be also order of n. And in if you talk about a time complexity, so we are iterating over all the number for all ith steps. What are what is the number of distinct ways to reach that step, right? And also one more thing, uh, what will be our final answer? So our final answer will be the number of ways to reach the nth step. So as we defined our dp of I as number of distinct ways to reach at the ith stage, so our answer will be dp of n, right? So dp of n will be the answer for the problem. Now one more thing, so here whenever one thing I also want to share with you, that whenever you see that your current state is just dependent upon some constant previous state, in whenever you solving the problem of dynamic programming, and when you see that your current state of dynamic programming is dependent on some previous some k, and it's not some constant number of states like 2 3 4. It's for in that cases what you can do, you can just instead of storing all the numbers, if you do not have to give the answer for query, instead of storing all answer for all the ith, I plus 2, I plus 3, I plus 4, I plus 5, you can just use the variables, because you need only two previous state, and you can just update your previous states with the current updated values, right? So let me tell you, so let's say we can last to last previous 0, last previous 0, current equals to 0, right? So we'll start with the first n equals to 1. So for 1 our current will be 1, right? Then we will current will be some last to last previous and last previous. Now we can just update our last previous with the current, and last to last previous with last previous, right? And last previous is equals to current, right? So this is the optimization for the space complexity. In that case we are not taking whole array, and our space complexity will be reduced to order of 1, right? So this is the idea about this problem. So let's directly jump into the code and try to code it. So what I have told you, that we will create one dp state int of dp of n, and we will initialize it with 0, right? And our dp of n will tell you that, so basically we'll just number of distinct ways to reach ith step. So we know that dp of 0 is equals to 0, and yeah, definitely your n will be never be less than 1, so we can also say that dp of 1 is equals to 1, for because we know the answer for dp of 1. Now we have two previous states. What we can do, we can iterate from I equals to 2 to I less than equal to n, and I plus plus. and dp of I equals to dp of I minus 1 plus dp of I minus 2, right? Return answer, which is dp of n. So this is what we have already discussed on iPad. Let's try to run it. Most probably it will give the correct answer. What we missed? Hmm? What we missed? Anything we did wrong? Okay, so it's fine. We can just use our mem set dp0 size of db. Right now it will give the correct answer. What we missed? Oh yeah, oh sorry, for dp0, because there is always a one step you'll take, because you are at that step. So for that you have to initialize your dp of 0 with 1. So try to run it now. Try to submit it. So this is accepted, and we have also discussed the optimized approach. So for that, what I will do, last int last previous is equals to 1, int last previous is equals to 1. Now for 2, int cur equals to 0. So what I'll see, cur equals to last previous plus last previous. Now last to last previous equals to last previous, and last previous is equals to cur, and I will just return the cur. And I will submit it, and it will give the absolutely correct answer. Oh yeah, sorry, missed it. That is one, yeah, because we started this for loop from 2, and we know that if the n equals to 1, we are returning this current as 1. So for in that case the answer will be 1 return. Now let's try to submit it. And it will be accepted. So this is about the first video. Thank you so much for watching it. I will so let's mark it as completed. I will upload the second video also. Thank you so much.